if I draw in in an equilateral triangle, if I draw in any of those points of concurrency, so let's say I draw in these two lines, these are going to be the same for all of that. And let's say I told you that the length of each side was 12. Okay. And I ask you, what is the radius of an inscribed circle? If we were to sketch our inscribed circle is going to be right here. So here is the radius. Do we know what this length is? Call this 1. So this is radius 1. This inscribed circle has a radius. We can find it one of two ways. First of all, we could say we created this little 30, 60, 90 triangle in here. If we look at this triangle, what is this length from here to here? It's half of the whole length or base, which is 6. And so now if the side opposite, the 60 degrees is 6, what does that mean the side opposite 30 degrees is going to be? Anybody recall the shortcut for that? Take that measure, divide by 3, multiply by root 3. So what is this height, or this length here? 3 goes into 6 twice, so we get 2 root 3. So here we have our length of 2 root 3. That is the radius of an inscribed circle. Okay, what if I asked you, what is the radius of a circumscribed circle? Okay, so here's that circle. Okay, so if we're looking at this circle, okay, here's our radius. So this is R2. Well, if this measure is 2 root 3, then what is the hypotenuse of this small right triangle going to be? Double that, or 4 root 3. So that means that this measure is 4 root 3, this one 2 root 3. So if, and what you're going to see for these, or first of all, are there any questions on finding those pieces? We could have also said, what is, if we know that this median is broken into a ratio of 1 to 2, this upper portion is twice 2 root 3, twice 2 root 3 tells you that this whole thing is 4 root 3. There's also the radius of that outer circle. Okay, the way that you're going to see many of these is one part of this will be shaded. So if I had asked you to identify the area of this shaded region here, to find the shaded region, you would need to take the area of the triangle, subtract the area of the inner circle, and that's the shaded part. If instead I gave you this whole shaded region, so the green shaded region, in the green shaded region, you take the area of the larger circle, subtract the area of the inner triangle, and that would give you that green shaded region. So you're going to use area formulas on this. You'll see how it breaks down. Oftentimes it's going to be dealing with equilateral triangles.